IC3D is a low-cost approach for automatic case analysis in complex 3D environments. It makes analysis of case data as comfortable as in desktop-based eye tracking. In the following, we will demonstrate how the IC3D approach can be applied to visual world paradigms. The target stimuli in this case are figures on the table. Here we use the SMI eye tracking classes, but the IC3D approach is compatible with all scene camera based systems. What you typically get from a scene camera based system is a video where the gaze cursor locates the current point of fixation. A human annotator will then have to go through all the videos and annotate the fixated figures. In our IC3D approach, we use 3D geometry models to do this task automatically. The 3D model of the target stimuli is thereby aligned to the real world based on fiducial markers. The tracking based on fiducial markers comes for free. However, if they interfere with the presentation of the stimuli, other tracking systems are also supported. In our example, participants have to identify a particular figure from a set of Lego Duplo figures based on a verbal instruction. For our analysis, we require the sequence of fixations on particular figures, the duration of fixations per figure, and the timing of fixations on the interlocutor. The standard procedure would be a manual annotation of the gaze videos. This is a time-consuming manual process which requires about half an hour per minute of recorded video. Human annotators might also vary in their interpretation of certain fixations and have thus to be controlled externally. Any changes to the coding manual or the areas of interest will require a full re-annotation of all videos. Using IC3D is easy. You need a basic 3D model of the target arrangement, in our case 23 coordinates and 3D boxes. You would also need to cover the area with printed markers. Tracking is done using computer vision on the scene camera video and no further hardware is required. Based on the tracked 3D position of the eye tracking device, we cast the visual line of sight into the 3D world and intersect this ray with the created 3D models. In the video, gaze direction is visualized by the green lines. The precision of the gaze direction is subject to the standard calibration procedure. The SMI eye tracking classes support binocular tracking, but you can also use IC3D with monocular systems. As can be seen in the video, the 3D target areas are nicely detected and a log file is written with the timestamp and the target of fixation for every frame of the scene camera video. IC3D works in real time, so you get an online feedback on tracking quality during your studies. You can also feed previously recorded videos and sample files into IC3D and do the analysis post hoc. This allows a re-analysis of previously recorded data to support an interactive, iterative update of your coding manuals. If you are interested to use IC3D, please contact us.